Now is I'm actually doing a heat cycle on it. In most steels, actually are heat treated between 1350 and 1800 degrees. What I'm doing is just bring this below transformation temperature to actually help normalize it some. So what I'm going to do is I'm going to take it, I'm going to wire brush it one more time to clean the scale off, and then I'm going to take one more heat at that lower temperature and thermocycle it. So there is actually the heat giving off and taking up. Did you see the color change? Did you see that quickly? Yeah. So we're going to do one more thermocycle at about 1300 degrees, and then we'll just leave it on the side for a few seconds.
And you can sense the temperature by the color? Or
Yeah. Yeah, the temperature and then the scale. You can see how the scale is forming.
Yep.
The neat thing about the temperature is that it's all dependent on ambient light. So if you have a really bright shop, then you can't see the temperature as good, because it's a higher temperature will actually show a lower temperature of the metal. So in other words, the more light, the less hot it looks. So being in direct sunlight is usually, a tough way to do it. So as you can see, it's actually just slightly bigger than that 3/4 of an inch mark. And that'll allow us to clean it up all the way. So what I'm doing now is setting the lines. This is actually going to be the initial setting of how everything is going to look as far as symmetry and the overall lines for how it's going to be when it's done. In the olden days, they actually had gauges that were actually just a slot that you would actually take and just try to stick it through. And that made it so it could actually be built a lot faster. So one of the aspects that doesn't get talked about much in the blacksmithing scene is actually filing. Filing in its own right was a specialized skill. And being able to file really, really well and accurately is a basic skill set for a blacksmith. Especially if you're involved with trade blacksmithing, or you're involved in doing fine work, like if you are doing guns or rifle work or something along those lines, that you should be able to file flat, smooth, and true. And in the olden days, they actually had filing classes when you went and served your apprenticeship. So you would actually learn how to file and make it be an accurate, like a 1, 2, 3 block, which today, as we know, is 1 inch by 2 inches by 3 inches. So one of the ways you can actually see what's taking place when you're filing is if the lines go all the way across the piece. That means that you're actually holding it flat and true. If you notice that the lines stop, it means that you're not actually holding it flat and true, and then you can see how they continue again. It's really such a neat facet. So what I'm doing now is I'm doing the initial roughing out, or the initial lines, setting of the lines. And then I'll come back in and do the final draw filing with a mill file, which will give it a nice finish. The hardest thing about chisels is because of how straight they are. And that really becomes where having, you know, extra help with flatters and all that kind of stuff really pays off. Bob, do you have a file card out here?
Yeah.
Probably one of the funniest thing about doing all this stuff is I love doing this kind of work, but it's time consuming, and so anytime that you look at doing something like this, it has to be more for the passion of it than actually doing it to make money. Everything's getting cleaned up. I'm not going to bring it to the 3/4 of an inch. We're going to leave it about 7/8.
It's slightly tapered back.
Yeah, it is. See it? Can you see it from where you were?
Yeah.
Got a slight to it, but there's a little bulge right in the middle. By the way, in the olden days, they actually had machines, big grinding belts that they would actually put these on, in the, you know, grinding wheels that they would actually do a lot of the, you know, once they became commercialized, that they would use to finish these. In small areas like we're in, they were, you know, still doing some of this by hand, but not very much of it.
Well, it's amazing to see things like Swan Company and Stanley, those huge rooms with endless 6-foot diameter grinding wheels.
It is pretty amazing, isn't
Imagine
it?
doing that all day?
No, not really. So today what happens also is a lot of people want to see the hand, you know, that something is handmade, that they actually will say, well, don't finish it all the way. Which, I don't know if that's a good or a bad thing. It just always seems funny to me.
Well, that...
Okay, we're on.
Okay, so what I've just done is I've gone from a mill bastard, a half-round mill bastard, into just a mill file, which is a lot finer finish. The lines have been set on the chisel, so now I'm getting ready to set the final finish just before heat treatment.
Thank you.
Really, the whole process and the way it all works is really unique.
Yeah, I was going to say the temperature doesn't matter, but the rate of getting there matters a great deal.
Yep.
So the
not to talk nicely about my own stuff, but this is just beautiful. This is just beautiful. It's such a shame that that part didn't take. That is just a gorgeous piece.
Okay, just roll it a little bit. Great.
Point would you put that shape in there?
That is actually forged in, depending on how good you are. It's usually... So what it is we've already cleaned the metal, and now we're actually getting ready for the hardening process. So right now I've made my fire bigger, and I'm actually taking the heat treating process. We're actually going to harden in this oil that I have sitting over here in this can. So I'm just bringing it up to temperature really slowly to get a good penetrating heat going all the way to the center of the high carbon steel. Once we're up to temperature, I'll come and plunge it in, and that'll give us our hardness we're looking for. And again, ideally we're looking for right around 1 inch in length of hardness. So we're not hardening the whole blade, just about 1 inch of it. What I've done is I've stuck it in the oil about that inch, and now I'm wiggling it back and forth. And as I wiggle it back and forth, it actually keeps the bubbles from creating a shrouding effect. So we can actually get it hardened and have most amount of liquid in contact with the steel. So you can see it didn't harden. So the problem when you're using oil is now you got to wait. You got to wait before to get below 400 degrees to actually see if it's hardened or not. 400 degrees, once it's been hardened, is the temperature at which it goes and does that the phase transition in the metal itself. I don't believe it actually took though. I think we're going to have to go hotter. Here, it took.
No, it did take?
Yeah, it did take. So listen.
Yeah, okay.
So it went under that 400 degrees. Here it sounds like glass now. So a lot of people also make the mistake of thinking that because you quench an oil, it takes a while for it to get underneath that threshold, that it didn't actually harden. So it's kind of neat. So you can see it's hardened to about right here. So there's basically about 3/4 of an inch. I was actually hoping for it to harden a little bit further back. But this should actually work. And if you notice now, is there a way to do a close-up?
Yeah.
You can actually see where the scale has popped off. And you can see now we have good hardness here. It's actually skating off. You can hear the difference. You can also see here where the scale now is actually popped off. You can see where there's some silver. Okay, so what I'm going to do now is I'm actually polishing it up in preparation for tempering. So what I'm going to do is remove all of this residue from the hardening process, and so there we have a nice shiny surface, and that'll allow for us to judge the color properly of what has actually been tempered and where it's actually going to. you can actually see again where the hardness actually took place on the change on the texture of the metal, as well as where it's cleaning off better. We pretty much want this to be all polished up before we actually go in for the tempering process, and all that oil residue to be removed. But we want to catch it as it's taking place. And because it's so thin, it may happen quick, so you got to kind of be ready for it to take place.
What are you actually doing at this point, Jeff?
I am tempering. So we've already gone through the hardening process. So now what we're doing is we're modifying the hardness that we did. So usually when you harden something, you're going for the maximum hardness. So in other words, martensite is your maximum hardness. And what we're doing now is we're moderating that or tempering it to make it just a little bit softer so it won't fracture because it's so brittle in that martensite stage.
Got it.
So this is what actually makes it a useful tool, makes it a successfully useful tool. See it temperature starting to change now? See it turning bronze?
Mm-hmm.
I gotta back it up. Okay, now I'm going your way.
Okay,
I'm
ready?
going right in the water. How anticlimactic is that, right?
That should be fine. You really don't.
Don't need more than that? Is that what you're trying to say?
They're not pulling it out of the hose.
That's okay? Me and my honey haven't had...
So this is fabricated in the washer?
Yes. All set? Do you guys understand the difference between wrought iron? This whole process that we're doing is wrought iron with steel. This is all done traditional. So it's kind of a process. These are such great calipers.
Those are just standard general calipers.
I know, these are awesome.
They're great for,
They're awesome.
I mean, they're indestructible too, I might add. Semi-indestructible.
Let me get my hammer. No, I'm just kidding. That's something someone would say online. Let me get my hammer. I can fix that for you.
Yeah, that's right. I'm a mechanical tester. I had a friend in college who was getting on the job, and he would have to go to job interviews, and he'd show up in coveralls with a ball-peen hammer, and his title was tester.
I love it. I love it.
Curiously, he never got a job.
Probably never wanted one, right?
That's exactly right.
Oops. May not be big enough. Maybe too big. Yeah. Let's see.
They got it. I'm sure they had it. Through it, but initially we had no.
Wooden mallet or?
Yeah, they're in the shop.
Oh, okay, forget it.
Well, just a minute, do you want to, there's a copper mallet here.
Okay.
Here.
Actually, I may,
Just be careful with that crack.
yeah, I may just go a little bit more. Maybe not.
What, just to drive it home?
Yeah, well, you already know. See, here's just a little bit smaller than here.
Yeah, so if you get it past that here.
Yeah. But at the same token, I'm like, do I really want to be
Try
banging
this.
on the hardened edge, which already has that funkiness in it?
Yeah, that's beautiful. That's great.
A little bit more, though. Just a little bit more.
Yeah, the trick is to put a tiny fillet on the shoulder of the thing.
Sure is.
If you don't, I can tell you where to
That is pretty darn good.
traditional marking.
You've done this.
Many, many years.
Show it to us. Yeah, and rotate it a little bit so we can see it. See the shine. It's like 45 degrees towards the light. There you go. Now rotate it a little bit. There you go. Keep going. All right, good, good. Thank you. Looks beautiful. Hang on. Tell us a little bit about this project. You're speechless.
So this is actually an item that we just finished up in Bolton. This is actually a carving chisel made out of wrought iron and high carbon steel. It was forged completely from a 5/8 square bar of wrought iron and part of the rasp that actually has the cutting edge. So just finished it up and we're just wrapping up this filming shoot.
Thank you. Okay.
Yeah, the real test of sharpness is to go through a piece of soft pine and have it clean.
Clean walls.
Okay, so what do you... And I think we can demonstrate that. Yeah, see how it doesn't tear the grain at all? This goes clean through it. Now this is what Jennifer warned us about, being careful about. The temptation is to just do that to pop it all out. So you do it very carefully. that enough?
I'll go a little bit more. Maybe talk about how it's cutting.
Yeah, it's cutting extremely well. We sharpened it with 400 grit, 1200 grit, 6000 ceramic, and it's literally razor sharp. And the real test is to be able to go into a piece of softwood, but like northern or eastern white pine, and have it cut very cleanly.
So it's
Something like maple.
so it's successful.
It is successful.
Good.
And it's, this is not the typical way. This is actually a difficult way of making a mortise. If you were doing this in any kind of hand tool production mode, you drill a series of 3/4 inch auger holes and then basically
Clean
it
out the
out.
waves. Okay, minute 30.